Number 5. The most powerful laser weapon. The image of futuristic laser weapons, as something reserved for sci-fi movies, is increasingly a thing of the past. The laser called Athena, short for Advanced Test High Energy Asset, is the most powerful laser weapon on Earth. Lockheed Martin, a global aerospace and defense company, showcased the 30-kilowatt high-power laser weapon in 2017. They were able to prove its effectiveness beyond doubt by shooting a vehicle from more than a mile away. The accuracy of the laser was also displayed, since they managed to shoot the hood specifically and effectively fry the vehicle's engine. The laser was mounted on a large, robust vehicle called the High Energy Laser Mobile Demonstrator. These kinds of weapons can provide a significant tactical advantage on battlefields, since they reach their target instantaneously and require no ammunition, just a very powerful energy source. With further development of these types of lasers, they will be able to defend against much larger threats and at greater distances in the future. Number 4. China's Silent Hunter. The Silent Hunter is the Chinese counter-drone laser weapon system. It was first shown at the G20 summit in Hangzhou in 2016. At an arms conference in Kazakhstan in 2018, it demonstrated its ability to destroy unmanned aerial vehicles from a distance of 1,000 feet. Its beam can cut through sheet steel and penetrate targets of 10mm thickness from a distance as much as 2,600 feet. It can also intercept low-altitude drones from 1,000 feet away and gun down moving targets and naval vessels. It's a portable, vehicle-based laser weapon. The exact power of the laser hasn't been disclosed, but it's reported to be between 30 to 100 kilowatts. Its developers have said that drones with large payloads are becoming increasingly accessible, and because they can be used as weapons for terror attacks in the future, lasers like these might become increasingly necessary and valuable as time passes. Number 3. The Texas Petawatt Laser. The Texas Petawatt laser was the most powerful operational laser when it was switched on for the first time in 2008. The laser has a peak power output of over 1 trillion watts. More specifically, 1 petawatt, or 1 million billion watts. Our mind can't even fathom this kind of power. When it is switched on for 1 trillionth of a second, it creates more power than all of the US power plants combined. So what is all that power supposed to be used for? Lasers this powerful are actually the only way for scientists to study space phenomena because they can be used to recreate the extreme conditions found in space. Any matter that these laser beams touch instantly vaporizes and turns into plasma, the fourth state of matter, which is extremely rare on Earth, but probably makes up 99% of matter in space. Ultra-powerful lasers can therefore allow scientists to study things like the atmosphere of stars and what space could have looked like right after the Big Bang. The laser's project manager said, "You'd have to go into space and hang out with an exploding star to observe what we plan to observe here in Texas." In addition to this, these lasers have many practical applications, like the research for alternative and clean energy generation or healthcare. Also, when it comes to particle research, ultra-powerful lasers like the Texas Petawatt can be an alternative to enormous particle accelerators, like CERN, because they're both smaller and less expensive. Such particle accelerators have also been used in new, effective cancer therapy techniques, but they are too large and expensive to have widespread use. Laser-based cancer therapy could make these techniques available to a far greater number of people. Number 2. The Osaka University LFEX laser. The Japanese Osaka University managed to fire what was the most powerful laser in the world in 2015. The laser, called LFEX, Laser for Fast Ignition Experiments, is a more than 300-foot-long beast with a peak power of 2 petawatts, or 2,000 trillion watts. Just a 50,000-watt laser is able to shoot down a drone at a distance of 2 kilometers. One way to conceptualize the LFEX's power is to try to imagine a light beam 1 billion times more powerful than a typical stadium floodlight, and then imagine it being concentrated onto a surface no larger than the size of a human hair. Despite the astounding power of lasers like the LFEX, their energy consumption isn't nearly as huge as one would presume. This is due to the fact that these lasers are fired at extremely short lengths of time, and since power is energy over time, a very small amount of energy can generate amazing power. The LFEX is mostly used for research into alternative and clean energy generation, as its primary purpose is the study of nuclear fission, an enormous source of energy which doesn't generate any radioactive waste like nuclear fission. It's the same process that creates and sustains the enormous energy of stars, and thanks to tools like the LFEX, humans can come one step closer to understanding and making use of that fascinating phenomenon. Number 1. The ELI-NP laser. The ELI-NP HPLS, or High Power Laser System, is an ultra-high intensity laser system developed by Thales and ELI-NP, the Extreme Light Infrastructure for Nuclear Physics project in Romania. ELI-NP was initiated by, among others, the 2018 Nobel Prize winner in physics, with the goal of establishing a sophisticated research center with the most powerful laser at its disposal. In 2019, the laser has been able to generate pulses at a power level of 10 petawatts, making it the most powerful laser on Earth. To bring this astounding number into perspective, this level of power amounts to 1/10 the power of the entire sun. Just imagine that kind of power concentrated in one single light beam. The development of the laser system began in France, and the subsystems were tested there until the laser was transferred and installed at the Mogorele facility near Bucharest in 2016. A team of Romanian and French engineers made the final touches in early 2019 and scaled it up to its tremendous power level. From the initial stages of this project to its completion, the laser's power was increased tenfold. On March 7, 2019, the laser managed to reach its peak power level of 10 petawatts after 4 hours of continuously delivering pulses of 7 petawatts. Of course, this was not an easy feat to accomplish. Thales, the company that partnered with ELI-NP for this project, invests 3 billion euros in research and development every year. There are 2 twin lasers making up the laser system, 10 petawatts each. This tremendous power will be used as the main instrument of a nuclear physics research facility, making it an invaluable tool for advancing the field. The laser has many potential applications, ranging from cancer therapy to particle research. It can do things like vaporize matter to create plasma, allowing scientists to explore what happens during a supernova. It can also be used to study the formation of heavy elements, create ion beams for cancer therapy, and for management of radioactive waste. This project, funded by the European Union, has represented a huge leap for the scientific community in the Czech Republic, Hungary, and Romania, and will undoubtedly contribute to research valuable for the scientific community worldwide. Honorable mentions: Bijov, the super laser. In 2017, British and Czech scientists took part in creating what they claim to be the most powerful pulse laser there is. It was developed by Britain's Central Laser Facility and the Czech State Research and Development project called HyLaser. Then it was named Bijov, after a mythical Czech strongman. The laser ended up weighing 22 tons, and its construction cost $48 million. It has an average power output of 1,000 watts, which was claimed to be the world record for pulse lasers at the time. Bijov is fundamentally different from its so-called peak power lasers. It is stronger in average power output than lasers with enormous peak power outputs, like the Texas Petawatt laser or the LFEX, because it's able to fire more frequently. Lasers like the Texas Petawatt laser or the LFEX reach their extremely high peak power outputs by releasing power in very short bursts, which makes them require long charging cycles between each shot. This laser is used as a tool in engineering for hardening metal surfaces, processing semiconductors, or micromachine materials, making them invaluable in the aeronautics, automotive, and power sectors. The Central Laser Facility Director pointed out that the technology developed in this project will be able to transform the application of high-power, high-energy lasers. The German military laser. A German company based in Dusseldorf called Rheinmetall Defense tested a 50-kilowatt high-energy laser at their proving ground facility in Switzerland in 2013. The test was passed with flying colors according to the company, and it was reported that their laser is able to destroy targets from over 1 kilometer away. The laser system consists of 2 laser modules of 30 and 20 kilowatts placed on a revolver gun air defense turrets, which are then attached to additional power modules. A specific type of technology called beam superimposing technology enables the laser to achieve high power by combining the 2 lasers to focus in a superimposed cumulative manner. During the test, the laser was able to slice through a 15mm thick steel girder from as far as 1 kilometer away. After that, at double the distance of 2 kilometers, it successfully shot down several drones moving at the crazy speed of 50 meters per second. Lastly, it managed to destroy a small ballistic target moving at the same speed, an 82mm steel ball simulating an incoming mortar round. All of this was done in bad weather that included rain, snow, even ice, and bright sunlight.